Hello students, welcome to classroom. Today we will be studying a very important topic which is called sign convention. This is very important for your exam. From the exam point of view itself, this is very important. Numericals come from this chapter, and if you want to solve the numericals, you have to have a good understanding of this topic. So I want you all to grab your pen or a pencil and a notebook and then start doing along with me so that we will learn together. So without wasting any time, let us straight go into the lesson. So sign conventions. Okay, what are we going to learn here? We are going to learn about the different terminologies like object, image, and focus again here. Okay, but this time we will be addressing their sign also, as the name of the topic itself suggests, sign conventions. Okay, so we'll be studying the signs. Okay, the sign, whether it will be a positive sign or a negative sign. Okay, it's between plus and minus only. Okay, so some values of image will be positive, some values of focus will be positive, some values of focus may be negative. So in which cases will it be negative, in which cases will it be positive? We are going to study all of this in this lecture today. So let us start. So in order to start this lesson, let us draw the mirrors. So we need ray diagram. So let us draw the mirrors. So let me draw a concave mirror on this side. Okay, I'll be drawing both the mirrors so that we will explain, so that I can explain to you at one go. So concave mirror, draw a concave mirror here. Okay, then the back side we will be representing it like this. Then draw the principal axis. Draw the principal axis. The point where the principal axis touches the mirror is called the pole. Mark it with capital P. Okay, capital P for pole. Now label the different points which are found on the principal axis. Which are the points? We have focus. So let's put the focus here. Okay, now I have been telling you how to mark this focus and how to mark the center of curvature. So what you should do is, you should first, okay, get a good measurement of how you have placed the focus with respect to the pole. So for me, I will use my hand here and get the measurement. Okay, and without moving this, I'll go and put my hand, one of my finger in the focus, and then get myself a rough value of it. So it will be here. My center of curvature will be here. Okay, now why am I doing this? I am doing this because I know of the relationship between R and F. We know that R, okay, is twice of focus. Now what is R? R is the distance from here to here, isn't it? No? Isn't it? R is the distance from here to here. Okay, the distance from P to C is known as R. So R is nothing but the distance between P to C. So if P, so focus is at the midpoint of, okay, is at the midpoint of R. So that's why the same distances, okay, I have to make sure that the distance, okay, is same. That way focus becomes the midpoint. All right, so let me erase this. We have already discussed about these things, but just time and again we need to revise them. So now focus and curvature are both found on the principal axis, so we have shown it. Okay, then we will show the object also. So let me extend this a little bit. Okay, and let me draw the object here. So let me draw the object here. This will be the object. Okay, then let me draw the image here. So let this be the image. Okay, let this be the image. Now let's draw the other mirror, which is the convex. So let's draw the convex mirror. So let's draw the convex mirror here. I think it's visible. So let's draw the convex mirror here. Then draw the principal axis. There is nothing much on the left side, so we'll have to extend it on the right side. I think this side may not be very good. Okay, so let me just bring it a little towards this side. Okay, yes, this will be better, I guess. Yes. Now this is the principal axis. Okay, and this is the back side of the mirror. This is a convex mirror, glass. This is the back side of the mirror. Then this is the pole. Okay, this is the pole. Now again, let's put the focus and the curvature here. Okay, since this is a convex mirror, image will be formed on this side. So I will draw the focus on this side and the curvature on this side. So let's just put the focus here. Okay, let this be the focus. Then take the measurement from P to F. Okay, and then go back and trace it here. Then you can put your C here. Okay, this is how it should be done, because F is the midpoint between P and C, and P and C is radius of curvature. Alright, so now let's draw the object here. So let us draw the object. Let this be the object here. Okay, let this be the object. And where will the image be? Okay, the image will be between P and F. So we can show the image here. I can show the image here. Let me show the image here like this. Okay, it will be an upright image because this is a virtual image. Okay, virtual images are upright. Upright means they are above the principal axis. This line is called the principal axis, whereas real images are inverted. This is a real image. Okay, this is inverted. It is below the principal axis. Object is upright. Object in both the cases, concave as well as convex, will be upright. Alright, now let us label them. Now first thing, okay, all measurements will be done from the pole. Okay, remember that. So whenever you are measuring, always start from the pole. Okay, somewhere let us write this. So let's write some points here. So star mark. Okay, all measurements from pole. Okay, this is very important. Okay, all measurements from pole. Okay, remember that. So all measurements from pole. So the pole is here. So let's measure the object, means object distance. So the object is here. Object is at this point. That means let us measure the distance between this point to this point. So which will be represented by U. Okay, so here you draw an arrow, and right here U, small letter U. Okay, and then it's pole, na? So let it go here. So this will be your U. What is U? U is object distance. Let us just write here. U is equal to object distance. Okay, in short, object distance. All right, now object distance is done. Now this is image, isn't it? So let's make the dot bigger. So from this point to this point will be the image distance. So let us do like this. This will be small letter V. Okay, and then it will be here. So this is V. Okay, this is V, image distance. So V is equal to image, IMG, image distance. Okay, then focal length. Okay, focal length. So here, so from here till here. Okay, this distance is called focal length. Okay, which is F. So F means focal length. So F is equal to focal length. Focal length. Okay, now let us go to the convex mirror. So same thing, this is the pole. All measurements from pole. So measurement will be done from here. Okay, so from this point to this point will be our object distance. So it will be U. All right, so U is object distance. Now where is the image? The image is here on this, on the right side of the mirror. So this is the right side, this is the left side. Okay, my left hand left side, my right hand right side. Okay, so this is the object distance done. Now let's label the image distance. So image distance will be from here to here. So let us just say from here till here is the image distance. I hope it is visible to you all. Okay, this is image distance. And focal length is here. Okay, from here. So let's draw from here till here. Nah? This dot is here, isn't it? So this will be your F. Already F. Okay, just show it F like that. So the distance from this point to this point is called focal length. The distance from this point to this point is called object distance, which is represented by U. So U represents object distance from the pole. Small v, small letter v represents image distance from which point? from pole. So from here to here, image distance. Let's come to concave mirror. V will be from pole to this point. Okay, this is called image distance, and F stands for focal length. So focal length is the length of the focus only. Okay, class. So length of the focus with respect to the pole. Remember, all measurements start from pole. All right. So these three, they belong to one set, so you can just put a box. Okay. Now we are done with U, V, and F. These are very important. Okay. So right now we have just discussed the symbols. Okay, which we will be using to denote object distance, image distance, and focal length. Okay. Now, what is next? Yes. Now, height of the image and height of the object. Let us always start with the object, because if there is no object, there will not be image. So object comes first, then the image. Without object, there cannot be any image. So always address the object first. Okay. So object is here. So what are we going to measure for the object? We are going to measure the height of the object. Okay. How tall is the object? How short is the object? So we will be measuring the height only. So height. So since we are going to measure height, it will be like this. Let's be HO. HO because height of the object. So H stands for height, O stands for object. So this is called height of the object. HO means height of object. Alright. Now, then what about what about image? What will it be? What symbol will it be? It will be HI, is it not? So it will be HI. So it will be H, small letter I. This will be the height of the image. Okay. So HI, small letter I, is equal to height of image. All right. Not difficult, isn't it? So far, I hope you are all following so far. So now let's go here and mark it also. So this is the object. So HO will be here. So HO is here. All right. Then image is here. So this will be HI. So this will be HI. Okay. So I request again to copy down this in your notebook. Okay. You will only learn better when you coordinate with writing. Okay. Your coordination between the hand and the brain. Okay. It's very effective. So please practice drawing. Okay. Practice a lot. You need to practice. Okay. That is one effective way of studying. So this also will belong to one set. So just put in another box. Now U, V, and F done. Then HO and HI done. Okay. Now something very important. Now we will go to the sign. Okay. All the conventions have been discussed. Okay. This can be, see, U, V, and F are conventions. HO, HI are conventions. So we are done with the conventions. Now we will go to the sign. Okay. Now one thing before I forget, let me say it out. Now the topic I have written here is sign convention, but sometimes this is also discussed as new Cartesian sign convention. Okay. So in some books or some teachers, or maybe in some books it may be written as new Cartesian sign convention. So what I want to tell you is that they are the same, new Cartesian sign convention. Okay. So in exam, if in exam your teacher, instead of saying sign convention, writes this topic, okay, understand that it is the same thing. Okay. Sign convention or new Cartesian sign convention, they mean the same thing. Okay. They mean the same thing, just that the name is different. Okay. So now let us continue further. Now let's go to the sign. Okay. Now to discuss about the sign, we have to do certain things. The first thing is we have to indicate the direction of light. So let us indicate the direction of light. Now how to indicate the direction of light? Okay. So above the figure, okay, you draw a big arrow like this. Draw a big arrow. Okay. Maybe I'll use a red marker for this one to indicate the direction of light. So let me just start from here. Okay. Yes. And I will write here direction of light. Direction of light. Okay, this is the direction of light. Let me draw another one here also. So from here, okay, this is the direction of light. Direction of light. Now this is very important. This is very important, okay, to discuss the sign. So now we will be discussing about the signs. Okay, the signs. Which value will have positive, which value will have negative. Okay, to understand that, the direction of light will help us. Now remember class that direction of light is always from the object to the mirror and never from the mirror to the object. I repeat once again, direction of light is always from the object to the mirror. That means light first falls on the object, then after falling on the object, then only light will fall on the mirror. Okay, in both the cases this is same. Light first falls on the object, then on the mirror, then it continues its journey. Okay, wherever it has to go, it will go. Okay, so remember, light always falls on the object first, then after which it will fall on the mirror. Or you can also understand like this, the direction of light is from left to right. Okay, you can also remember like this, it is from left to right. Same thing here, it's only written here, left side is not right side, so left to right. All right, so now that the direction of light has been shown, now let us start. Let us first start with u. Okay, let us find out what sign will u have. So what is u? U is object distance. Where is our object? Our object is here. So let me use red marker again. So the object is here. So what sign will the object have? Well, in order to determine the sign of the object, where will we go? We will go to the pole. Why to the pole? Remember what we have written earlier. All measurements starts from pole. Very important. Okay, very important statement. All measurements start from the pole. So let us be here. Every time we have to measure anything, we should start from here. I repeat again, every time we have to measure anything, we have to start from here. So we are here, and what are we going to do? We are going to measure object distance. So we will be walking. We will start our walking from here and walk all the way to the object, okay, which is this point. So now let us start walking. Okay, why are we walking? We are walking so that we will find the measurement of the object. Okay, so how far is the object from the pole? To measure that, we are walking. So as we walk, now the direction of our walking is this, in this direction. Now we are walking towards the object. We started from here, so we're walking in this direction. We are walking towards the left. Okay, as you walk, look up. You look up. Why are you looking up? You are looking up. Okay, you are looking up to check your direction. Okay, to check your direction with respect to the direction of light. I repeat once again, as you walk towards the object, look up. If you look up, okay, you are looking up to check your direction with respect to the direction of light. So as you look up, what will you see? You will find that you are walking opposite to the direction of light. Light is going like this. Okay, the direction of light is like this, from left to right, and you are moving right to left. So your direction and the light direction is like this. You are going like this. This is opposite, is not? So you are moving. As you move from P to U, as you move from P to the object, your direction of movement is opposite to the direction of light. In these cases, you will get negative value. So U value here will be minus. So U will be minus. Okay, U will be minus. Now let's go and check here whether for convex mirror U will be positive or negative. So once again, all measurements are from pole. So you are here and you have to go here because the object is here. So you will be moving in this direction. Okay, as you walk, look up. As you look up, you will find that you are walking opposite to the direction of light. Light is going like this and you are moving like this. So see, your movement is opposite to the direction of light. If we are moving opposite to the direction of light, what sign do we get? We get negative. So object distance in both the cases, concave as well as convex, will be negative. Okay, Are we clear? So object distance will be negative, reason being because the direction of our movement to measure the object is against the direction of light. Alright, so we will get negative u value. Okay, the value of object, the value of u is negative for this reason, because our movement direction is opposite to the direction of light. Light is moving from left to right and we are moving from right to left. Is that clear? Alright. Now see, now that you know that object distance is will be negative in both the cases. Okay, always remember, always remember that object will always be negative. Okay, and we have just now we have discussed, okay, that it is true that it will be always negative. Okay, so object distance, remember, it will always be negative. For image distance, okay, it will depend. So let us find out. Okay, like in this scenario, in this case, what will be the image distance, or what sign will the image distance have? What sign will v have? So let us find. Our image is here. Okay, our image is here, and then we should be here. We will go here because all measurements start from pole. So we will be moving towards this point. So let us move. So as I move, this is my direction of movement. Okay, now as you move to measure image distance, look up. If you look up, you are looking at the direction of light. Now check your movement, check the direction of the movement with respect to the direction of light. Are you moving along the direction of light or opposite to the direction of light? Your movement is opposite again. If it is opposite, what sign will you get? You should be getting negative. So for this particular diagram, v will be negative. Okay, here v will be negative. Okay, v will be negative. But I will not write here because see, there are 6 cases for concave mirror. So in the 6th case, we will be getting positive. Okay, but the remaining 5 cases, we will be getting negative, because in the remaining 5 cases, images are formed on the left side. Okay, so remember, you need not worry about image distance actually, because you will be finding the value of v by calculation. So when you calculate, the sign will automatically, okay, if you address the object distance correctly and if you address the focal length correctly, the sign will automatically be correct by itself. So remember that whenever we move opposite to the direction of light, we will be getting a negative value. So if we consider this case, since the image is formed here, it will be negative. Correct? It will be negative. Okay, it will be negative. Remember that. Okay, or we can just write, let me just write negative. For this particular ray diagram, this will be negative. And what about here? Now, measurement will be done from here. Okay, so image is here. So you will have to move from here to this point. So you are moving like this now. Now, as you move, look up. Now, as you look up, check out your direction with respect to the direction of light. Light is moving from left to right. You are also moving from left to right. So this time, your direction is along the direction of light. Yes or no? You are moving along the direction of light. Yes or no? Yes, nah? So in this case, you will be getting positive value. So the value of v will be positive. Okay, when do you get positive? You will get positive when the direction of your movement and the direction of light are in the same direction. Okay, so when you move along the direction of light, that time you will be getting a positive value. But when you move opposite to the direction of light, you will be getting a negative value. Are we clear? Are we clear on this note? All right, now let's move to the focus. Okay, let's move to the focus. So what about focal length? Now remember, focal length will always be considered for the image side. Okay, now look at this diagram. Now the image is formed on the left hand side, so we will be considering the focus on the left hand side. Okay, now you go and look here, now here the image is formed on the right hand side, so we will be considering the focus on the right hand side. Okay, so focus you will always consider for the image side. On which side that the image is formed, that focus will be considered. So let us come back here. Here in this case, the image is formed on the left hand side. That means we will be considering this focus. So let's measure the focus. So the focus is here. So this is the focus point. So we are going to measure focus. So we have to start from the pole. So we are here again. Let's measure focus. So as I walk to measure the focus, again I am moving in this direction. I'm moving from right to left. As I walk towards this direction, as I move along this direction, I look up. When I look up, I'm looking up to check my direction with respect to the direction of light. I'm checking whether I'm moving along, okay, I'm moving along, or am I moving opposite to the direction of light. Now what do I see? I see that my movement direction and the direction of light is opposite. That means it is like this again. It is like this. Opposite. Alright? It is opposite. Since it is opposite, what sign will I get? Negative, is it not? So focus here will be negative. Got it? Focus here will be negative. Why negative? Because the direction of my movement with respect to the direction of light is opposite. So I'll be getting negative. Clear? Now we go here. Okay, we go here. Now when we go here, we have to consider this focus, because this is the focus on the image side. Image is from here, so I have to consider this focus. So now let us measure this focal length. So I am here and I will move. So I'll move towards the focus. So as I move towards the focus, this is my direction again. Check out my direction and check out the direction of light. Am I moving along the direction of light, or am I moving opposite to the direction of light? What is your answer? Yes, I am moving along the direction of light. If I move along the direction of light, if the direction of my movement and the direction of the light is together, what sign do I get? I get positive. Yes, so focal length here will be positive. Are we clear? Okay, so that's it. Okay, that is it. So this is the sign Cartesian. All right, this is the sign Cartesian, not very difficult. Okay, so for this mirror, the object is negative. Remember, object, okay, for object you need not worry, object will always be negative. Okay, object will always be negative. Whenever you are doing the numericals, always do not forget to put minus there. Okay, always put negative there, because object will always be negative. Why? You know, because object will always be kept, okay, on the left side of the mirror. Whether it is concave or convex, look at the object, it is always on the left side. It is always on the left side. So the pole is here, the pole is here. So while measuring the object, you will be moving towards left side. Light is traveling towards right side. While measuring the object, you will be moving towards the left side. Light is traveling towards the right side. So in both the cases, you will get negative value only. So without wasting time, you can just remember that you will always be negative. Just write minus on whatever value of object the question has given to you. Alright, I hope it is clear. Now next, what we will do, next we will talk about these two now. Okay, the height of the object and the height of the image. For this you have to remember, okay, a very important point, which is yes, measurements above the principal axis are taken as positive, whereas measurements below the principal axis are taken as negative. Okay, this is a very important point. Measurements above the principal axis are taken as positive. Okay, they are taken as positive. Above the principal axis means positive. Okay, below the principal axis means negative. All right, let us check out. Now we are going to find the sign for the height of the object and the height of the image. So let's go here. This is the height of the object. Okay, the height of the object is here. Now this is the principal axis. This line is the principal axis. This line is the principal axis. It is on the principal axis that you will find focal length, you will find the center of curvature. Okay, all of these are in the in the principal axis only. So this line is the principal axis. Now look at the object. The object is standing above the principal axis. Okay, this side is called the up side and this side is called the down side. Okay, so this side is the up side and this side is the down side. Okay, so measurements above the principal axis are taken as positive. So the object is above the principal axis, so HO will be positive. Alright, HO will be positive. Got it? Because it is above the principal axis. What about the image here? The image is here and the image is below the principal axis. That means it's down, okay, below. It's below the principal axis. This is the principal axis. The image is below the principal axis. Measurements taken below the principal axis are negative. So HI will be negative here. Follow? Next, here, we go here. Now, object is here. This is object. The object is above the principal axis. This line that you see is the principal axis. So this line is the principal axis. So your eyes should be focused here. The object is here. Is it above the principal axis or below the principal axis? The object is always above the principal axis. So the sign that it will have is plus. It will have plus. Okay. Now let us go and see the image. This is the image. Okay. The image. Now look at the image. Is the image above the principal axis or below the principal axis? In this case, the image is also above the principal axis. So here the sign that it will carry will be positive. Are we clear? Okay, so this is sign Cartesian. Okay, so I believe that I am able to help you, okay, in clearing your doubt here. Okay, so if you still have any doubt, please rewind the video. That is the advantage of recorded classes. That is the advantage of learning from recorded classes. We can rewind again and again to those part where we are confused. Okay, and then after some time you will be able to do it. So in today's class, this is what we have discussed. Okay, in the next video, in the next class, we'll talk about mirror formula, magnification,